Hey guys, so now we are going to move on into chapter number 7, and we're going to start with confidence intervals. Now, guys, you need to get good at this because basically the rest of this class has something to do with confidence intervals. It's very repetitive, and once you get it, it becomes really easy. So we'll see what we got. Hopefully you can get it, and we'll go on from there. So basically what we want to do is we want to start by finding a confidence interval for the mean when the standard deviation, the population standard deviation, is known. Okay. So we're going to start out. We're going to give you a procedure here. Okay. We know that x bar is a point estimate and we don't know where it lies on the distribution. You know, the little picture that we make. Of sample means. For example, we might have some data that says that x bar is 252, and we know that that's somewhere on the normal distribution, but we don't know if it's to the right of the mean, if it's like 2 or 3 standard deviations away, or if it's to the left of the mean, or where it lies on the distribution of means. So we need to figure out what the actual mean is, or at least we need to have some sort of confidence as to how well we feel it represents the true mean. So basically right now, because it's a point estimate, we have no confidence. Okay. What we want to do then is we need to make sure that x bar is a good estimator of the true population mean, or in other words, mu. Okay. In order for that to happen, it must be unbiased, mu of x bar equals mu. It must be consistent, that is, as n increases, or the number of samples that we take, x bar, or the point mean, will approach mu. Okay, and the last thing it needs to be is relatively efficient. Now, what in the world does that mean? It has to be more efficient than I am writing with this stylus. We want to use the stat with smallest variance. All right, so how are we going to do all this? How is this fun stuff going to happen? Well, what we're going to do is we are going to now build a confidence interval around X bar. And what is a confidence interval? It is just simply, it is an interval with a set probability of including the true mu, or the true sample mean. Okay. So what we're going to have a formula, okay? The confidence interval is going, and this is on your blue sheet, and we are in chapter 7. So it's going to be X bar minus Z of alpha over 2 times sigma over the square root of n is less than mu, which is less than X bar plus Z of alpha over 2 times sigma over the square root of n. Now, Z of X bar over 2 times sigma over the square root of n, that has a name. This is a name that you need to know. This is the max error of the estimate. Okay. Now, of course, this big long equation can be written in a little bit shorter form. It's X bar plus or minus Z of alpha over 2 times sigma over the square root of n. Now, if we're going to do a Z confidence interval, we must know the standard deviation of the population. All right, that is extremely important. I'm going to put a little star here. For a Z, we must know sigma. Now that indicates that there are going to be other types of confidence intervals, and there are, okay? So basically what's going to happen is you're going to have to understand what you've been given so that you can come up with the proper confidence interval. It sounds complicated, but it really and truly isn't. Okay. Another thing you need to know is we need to talk about n. If n is less than 30, pop must, I'll write it on the next part. If n less than 30, population must be normal. You know how in all these problems I keep saying assume normality, blah 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 blah, all that fun stuff? Well, that's what you got to do. You got to assume normality. Okay. So let's do a couple of problems. Okay. So first, at a large frat party, okay, so what I'm going to do is I'm going to pause the recording here and write the rest of the problem out, and then you can read it. Okay, so hopefully you see, if n is at a large frat party, 30 random students were tested for alcohol. Their blood alcohol level was found to be 0.07 with a sigma, population standard deviation, of 0.02. Find the 95% confidence interval for the true mean. Okay, one of the things that you'll want to do is you'll want to understand that, first off, alpha is just simply 1 minus CI in decimal form. So alpha is going to be 1 minus 0.95 or 0.05. Why is that important? Because you want alpha over 2. Well, alpha over 2 is going to be half of 0.05, which is 0.025. Okay. What does that 0.025 mean? Well, let's take a look at that. Here we have our normal distribution. Okay. Here and here we have some numbers. Okay. Here is our mean. This is 95% of the data. All this in here, that's 95%. This side and this side are alpha over 2. Okay, so that's 0.025. And this is 0.025. So what you do is you look on your chart, on your blue chart, and you find the z-score that goes with an alpha over 2 of 0.025. And I'll show you an easy way to do this in later lessons. So I get 1.96 and negative 1.96. Hopefully you all see that. Okay. So what do we do? Well, now that we know what the z of alpha over 2 is, it's really easy. Our formula says we have x bar plus or minus z of alpha over 2 times sigma over the square root of n. Well, what were our numbers? X bar was 0.07 plus or minus 1.96. Notice this is a positive, this is a negative. That's where the plus and minus come in. Okay. We have 0.02, which was sigma, over the square root of 30. Now here, what happens typically is students forget to take the square root of 30 first. So things go a little bit awry. Now, the big thing for you, you can never have, when you're doing a z-test, whatever this number comes out to be, you can never have more digits than what this number is. So whatever your x bar is, that's what you have to limit that to. So if you do this math and you round it to the proper place, it's 0.01. So that means that we have 0.06 is going to be less than mu, which is going to be less than 0.08. This is my confidence interval, guys. Now, how confident am I in that interval? You have to tell me in a sentence. Okay, well, we said that we wanted to be 95% confident, and that's what we used. So I am 95% confident that the true mean BAC, also known as blood alcohol content, is between 0.06 and 0.08. Guys, you've got to get used to writing this type of a sentence. This is the way that you report your data. Okay? And that's all there really is to it. That was a very basic problem. We're going to step it up again a little bit for our next problem. And then we're going to do one more example. And then I want you to actually watch these videos a couple of times, this video a couple of times. That way it'll help you out a little bit so that you can feel like, oh, maybe I do understand this. Okay, so 2 more problems. Now, once again, I'm going to pause the video while I write the problem on the screen. Okay. So here we are. A random sample of 49 households were asked how many hours they spent on their kids' sports. The mean was 16.4 with a sigma of 3.6 hours. Find the 99% confidence interval for mu. All right. So again, the best thing to do is start with a picture. Now this time I want 99% of the data to be in here, which means how much do I want out here? I just simply want half of 1%, which would be 0.005, and this would also be 0.005. Okay. Alpha is simply 1 minus 0.99, which is 0.01. So alpha over 2 is equal to 0.005. Because remember, we want to be 99% sure that the mean is actually somewhere between this point and this point, the true mean. Okay, so where do we go from here? The big thing we need to do is we need to look on our charts, on our blue table, and find 0.005 as a probability and figure out what the z-score is. Well, hopefully at this point you can say, oh, well, that's pretty straightforward, Mr. Drum. That's 2.58. And the other z-score is negative 2.58. Okay? So what does that mean we're going to do? Well, let's plug stuff into our formula. Okay? Remember, our formula is x bar plus or minus z of alpha over 2 times sigma over the square root of n. Remember, guys, you can stop these videos and rewind if you need to. All right, x bar was 16.4 plus or minus z of alpha over 2, which was 2.58, times 3.6 over the square root of 49. Please do your math properly. 16.4 tells me that this number here, whatever it is, when I multiply it out, I cannot go any further than the tenths position. So that's just simply 1.3. Okay? And then all you have to do is a little bit of math. You have 15.1 is less than mu, which is less than 17.7. And again, you have to give me your conclusion. You have to do it. Okay, don't be lazy. So I am. How confident am I? I'm 99% confident. Of what? I'm 99% confident my interval. And remember, guys, make sure you write the interval down. If you don't write down the interval, I don't know what you're talking about. Contains the true mean what? Amount of time parents spend on their kids' sports. Okay, you gotta tell me what you're confident of, and you gotta tell me why. Okay, or what it is. What it is you're talking about. Okay. And actually, guys, I'm gonna stop there. I think that's enough for today. Go back and watch this again, and tomorrow, Tuesday, I'll continue on because there's another section to this, and I'll give you your first bit of homework tomorrow. All right, have a great day.